Everybody. My name is Adrian Goins. Welcome to today's session of Getting Started with Kubernetes and Rancher. We will start the webinar slowly to let everybody else roll in from the lobby, and then we will get started. I'm excited to be here today with you. I am joining this from the Central Valley of Chile, where everything's actually quite peaceful and beautiful. Things in Chile haven't been peaceful and beautiful lately, so I'm actually kind of excited that we still have internet access and that I can do this training. All right, so we have a lot to cover today. Let us get started. First of all, some housekeeping items. Today we're going to give you a technical introduction to Kubernetes, and we're also going to introduce you to Rancher. I've done these for a while now, and I try to mix it up to keep it interesting. So, hopefully the changes that I made for today will, hopefully they'll be good. As with all things Rancher, we try to keep the slides to a minimum. We do lots of demoing. So, I've got like some basic slides, but mostly you're going to see me in a terminal and in a browser showing you how to do stuff. I used to actually be joined by Matthew Shear for these, and he would actually do this part of the introduction to the emceeing, and he would also handle answering questions and stuff, but now it's just me. So I want you to ask questions. I want you to ask questions as soon as you think of them. There's a little questions panel in the GoToWebinar, whatever, the little interface thing there. So ask your questions there, and I will pause a couple times throughout the thing to take a look at questions. But because it's just me, I need you to help me out and try to keep your questions on topic. So if there's something that I've demoed that you want more information on, great. If you want to know more about Rancher, great. If you want to know more about Kubernetes, great. If you have a specific problem about why something does or doesn't work in your Rancher or Kubernetes installation, I will try to answer that if we have time and if I'm able to and if it's relevant for everybody. But if I don't, then it's not because I hate you. It's just because it's just me. As you'll find out in a second, we have a whole community on Slack. In fact, let me jump forward to that. But first, here I am. My name's Adrian Goins. That's what I look like. Here's a bunch of ways that you can contact me. I also have a YouTube channel where I make videos on Kubernetes and Rancher, and I will make videos for pretty much anything that you guys want to see, but we'll talk about that at the end. If you are in the Twitterverse and you want to say, hey, I'm in an awesome training with Rancher, please tag it with Rancher Training and or Rancher Kubernetes, Rancher Kates, so that other people can search for that and, so we can do all of that businessy, socially stuff that other people do besides me. I'm actually really bad at the whole social media thing because I live by myself, my wife, in a farm in the middle of Chile. It's okay if you have no Kubernetes experience. In fact, we expect you to have no Kubernetes experience. We hope that you have some basic Docker experience because we're not going to cover the fundamentals of containers, but even if you don't, that's fine. You'll be able to keep up. Rancher has tremendous resources available, and one of them is the Rancher documentation. We'll actually be starting out of there in a moment. So you can go to, gosh, that's a really terrible URL. If you want to find a better place, you can actually just go to rancher.com/docs, and this will drop you in at the top level. And from there, you can get documentation and information on various things that we have going on. If you want to follow along, you can actually launch your own instance of Rancher the same way that I'm doing, and you can also launch your own version of K3s, which is what we'll be using for the Kubernetes portion of today's training. So you can do that, you can follow along. If not, this is also being recorded. In fact, let me make sure that it's being recorded. It's supposed to be recorded. Wow, my GoToWebinar dashboard thing doesn't work. Yes, it's being recorded. So now there's a recording of me wondering if it's being recorded. You will get a copy of this at the end, and sometimes we run long because I talk too much. So don't sweat that either. If you have to drop off for another commitment, well, it's being recorded. So you can watch it again at the end. Now I gotta find the other thing that I was looking for. The questions thing. We also have resources available for you. We have Slack. So if you don't have an account on the Rancher user Slack already, you can go to slack.rancher.io, give us your email address, request an invitation, and then you can join. When you join, there is a channel called Online Training, which is a place where, since you guys can't really talk to each other here, you're welcome to join there and talk to each other and make fun of me and the jokes that I make, which are terrible. But you can also come back to the online training channel afterwards. We use it for every single training. So you can come back, you can watch the trainings again, you can participate with other people. The community that exists around Rancher is fantastic. So as I was starting to say earlier, if you have questions that I'm not able to answer today, you can go to the Rancher user Slack, go to general or go to Kubernetes, and you can ask your questions there. Rancher engineers are in there, and many people from the Rancher community are there. There are thousands of people registered, and at any given moment in time, there are anywhere from 100 to several hundred people logged in. We also have the Rancher forums, which is a better place if you want to ask questions or look for information that's a little bit longer running, since you can't really search Slack, but you can search the forums. I recommend you start with Slack and then browse the forums as well for answers. Hey, look at that. This is the part where Matthew normally says, hey, Adrian, are you ready? And I say, yes, I am. And we dive in. I don't know where you are in Kubernetes. In fact, you know what? Before we start, let me kick off a poll here so that you can tell me where you are with Kubernetes. So let's launch that, and we should, hopefully you see that there's a poll up on your screen. Nobody's answering the poll, really? Huh. Ah, there we go. Now we're getting people answering. All right. All right, we'll run this for another few seconds. It looks like we've got about 80% of you, 85, 90. Oh man, that's great. All right, so we have, most of the people here are just starting out. A handful of people don't know much about Kubernetes, and we've got 6% of the people here that know everything there is to know about Kubernetes, which is great. Please find me on the Rancher user Slack afterwards. Send me your name, send me your CV, and we'll hire you to do these trainings. Cool. Since most of you are just starting out, Kubernetes is, well, it's a framework. It's extremely powerful, it's extremely flexible, but in order for it to be those things, it's not going to tell you what to do. It's going to give you tools to do things. You still have to know what you want to do, and there are many different ways to accomplish your objectives. So there's not one specific way. As we're going through the class today, I'll show you lots of different ways to do effectively the same thing so that you can decide what works best for you. But because Kubernetes wants to maintain its flexibility, there's a point at which it can't do things. So it's not going to, for example, tell you how to interface with a backend identity provider. It's not going to tell you how to do backups. It's not going to tell you how to do multi-cluster, cross-cluster replication, single cluster multi-tenancy. And if you are left to go figure those things out, well, that's, I don't know. I like to say that we want to get to where we can use the platform. We don't want to spend so much time working on the platform that we can't actually use it to do the things that we need to do. So at Rancher, we have strived to build something that bridges those gaps, something that lets you move as quickly as possible from I don't have anything to I have a fully functioning Kubernetes cluster with the means to manage it. And in order to do that, we've done two things. We've abstracted away some of the unnecessarily complicated stuff that goes on with Kubernetes. We've consolidated a bunch of things where you would otherwise have to go to lots of different places to do stuff within Kubernetes. And then we've embedded tools from the Cloud Native Computing Foundation, such as Prometheus and Grafana and a bunch of other stuff, so that you don't have to try and figure out how you're supposed to install these things to get benefits for your cluster, like backups and monitoring and stuff like that. But look at this chart. Kubernetes is a commodity. It's like electricity. I don't particularly care where my electricity comes from. What I care about is that when I turn on the light switch, the lights come on. Kubernetes is the same thing. You can get your Kubernetes from pretty much anywhere, and you can use it with Rancher. So you can deploy it in the cloud. You can deploy it on bare metal. You can use hosted Kubernetes providers. You can bring us a Kubernetes distribution certified by the Cloud Native Computing Foundation, and we don't even really care where that came from as long as it's certified, because that guarantees that it's authentic Kubernetes. So Rancher has its own data center design Kubernetes distribution called RKE. We also have K3S, which is not in this slide, but you'll see it today. You can get hosted Kubernetes from any of the big three. You can use your own Kubernetes. You can use kubeadm. We don't care. If you want to use Rancher to deploy Kubernetes, that's great. Give us your cloud provider credentials. And I say give us, but it's not actually true. You enter that into the interface. We never actually see it. And we can stand up cloud infrastructure and then install Kubernetes into it and wire it back to the Rancher server. We can provision hosted Kubernetes solutions for you. We can import running clusters. So if you already have Kubernetes clusters out there in the wild, great. We'll give you a kubectl apply command. You can import them into Rancher and you can start managing them that way. And if none of that fits, if you use another provisioner like Ansible or Puppet or Terraform or Chef or Cloud Init or auto scaling groups or shell scripts or whatever, well, that's fine too. All we actually need is an operating system with a supported version of Docker, and we will give you a Docker run command that you can run to deploy Kubernetes into those nodes and wire them together into a cluster and wire that back into the Rancher server. All of this it takes less time to do it than the time it took for me to explain it. And then once we have those clusters inside of Rancher, a single Rancher server deployment can manage hundreds of Kubernetes clusters. And that allows us to start doing things like centralized role-based access control. So you can wire Rancher into something like Active Directory or GitHub or any of the number of other providers, create global policies and start applying those policies across all of your clusters. Now you have a uniform way to manage access to those clusters through Rancher that separates you from having to manage access credentials and all these different providers and figure out who's got access to what and so on and so forth. Above all the global stuff, and I'll go into all of this in more detail when we get to the Rancher portion at the end, but above all of that, we have all of this application management functionality that we brought. We have a very effective user interface. We've got an application catalog that gives you a fast way to deploy applications that your stuff might need, like databases and various other things. We interface with CI/CD systems. We've got integrated monitoring, log shipping, all of those, what the industry calls day two operations that are basically, okay, you got a Kubernetes cluster, but there's a bunch of other stuff you have to do with it. And going back to what I said earlier, we want to get you as operational as we can, as quickly as we can. Ordinarily, I start with a Rancher installation, and then I go and I do an RKE installation, but we're not going to do that. I need to switch these slides around. Instead, we are going to deploy Kubernetes. So there is a fantastic utility created by a guy named Alex Ellis called Ketchup. It's actually a Kubernetes cluster in under a minute. So let's use that. I have two nodes here. I have one that we're going to use for the Rancher server, and I have another one that we're going to use for the single node K3s installation. So with that, Ketchup is going to SSH into the system. It'll go ahead and pull down K3s. It'll install it, and then it'll give me back a Kubernetes config file that we will now start to use. So that's how long it took to install Kubernetes on that node. K3s is a super lightweight Kubernetes distribution. It itself is less than 40 megabytes, but it needs 512 megabytes of RAM to run all of Kubernetes. This means that the rest of the RAM that you have on your system is available for you to use for actual things. It also makes it perfect for resource-constrained environments like edge deployments, Raspberry Pi, any type of ARM processor, lightweight nodes, VPSs, places where you might want to run Kubernetes, but you don't necessarily want to pay. This is called kubectl or kubectl or kubectl. I don't like kubectl. I'll either say kubectl or kubectl, depending on the mood that I'm in. You can set an environment variable, kubeconfig, to point to a Kubernetes config file, which is all of this garbage that was printed out on the screen up above. And now we should be able to run kubectl get nodes. And there we go. We see our node. If you are using bash, so what you just saw there, that set-x, I actually use the fish shell. If you're using bash, you're going to do something like that to export kubeconfig. But however you get it into the kubeconfig environment variable is fine. So now that we have a Kubernetes cluster, and now that you guys can actually see the screen, let's talk about Kubernetes. Kubernetes consists of building blocks. They're blocks of stuff that you assemble into an application. Lots of people get freaked out about Kubernetes because it can be, I mean, it's massive. They speculate now that Kubernetes has gotten to the size where no single person knows everything about Kubernetes. But to get started, you don't need to know everything about Kubernetes. You need to know about really 4 things. There's 5 here, but whatever. Pods, deployments, services, and ingresses. So those are the things that we're going to cover today. Pods are the smallest unit that you can deploy in Kubernetes. They are one or more containers that share storage and networking and some other stuff that doesn't matter for the sake of today. So storage and networking. If you've ever tried to deploy anything just using Docker, then you've encountered trying to link containers together. You also have a problem with doing stuff with Docker where you end up building containers that have multiple things running inside of them, and then you have to get into service management and process management and init management and all of these other things that you don't want to do. The best practice for building anything with a container is that your container does a single thing. It runs one process and that's all that it does. And in theory, well, that's easy. But in actuality, when you've got web servers talking to application servers, talking to databases, talking to caching engines, talking to external stuff, that theory is a lot harder to maintain. Kubernetes pods make that easier. If you're new and you're concerned about the lexicon of Kubernetes using different terms, most of the time your pod will have one container in it. So it's generally safe to think of just a pod as a container. And certainly for today, that's fine. When you need to have pods with multiple containers, you'll know and you'll understand. Here's an example of 2 containers in a pod that perform some function. You've got a file puller that pulls stuff from a content management system that saves it to a volume, and then a web server that pulls that content from the volume and sends it off to consumers when they request it. This is a good representation of a unit of functionality, and you want to consider what your units of functionality are when you're designing your Kubernetes applications. Pods are what you will scale when you need more power in your application. So when you have more users than what you have resources available, you'll scale up the number of replicas, copies of your pod, to handle that additional load. For that reason, you want to make sure that the thing that you're scaling from 1 to 10, 1 to whatever, is appropriate. You're not going to build a pod that has a web server and a database server inside, because if you need 10 copies of the web server, you don't also need 10 copies of the database server, none of which would be able to communicate with each other. Generally, pods are things like Apache PHP or something like this with a custom thing and a web server, networking applications, things that represent a piece of your application. Everything in Kubernetes is written in YAML. YAML, nobody wants to write YAML, but you need to understand what it is and what it's doing so that you can do it in a different way and not suffer. But basically, they're called manifests. And here's the manifest for a pod. So you have API version, kind, metadata, and spec. API version tells Kubernetes where to find information in its API definition about the thing that you're telling it to manage, which in this case is a pod. Metadata we'll talk about in a second. Under spec, we have the definition of whatever this thing is. This is a pod. So in the pod spec, there's lots of stuff that you can provide, but you don't have to provide everything. The basic thing that you have to provide is what containers the pod should run. In this case, we have one called myappcontainer. The image is going to be busybox, and we're going to override the default command with this command. That looks like this. When you want to create something using kubectl, you can use kubectl create, or you can just use kubectl apply. So generally you create something and then you would make changes to it and you would apply those changes. But if you apply a change to an object that doesn't exist, Kubernetes is smart enough to create it for you. So in this case, we can just say kubectl apply, and we're going to tell it to use the pod.yaml file to do it. Now notice this is going to echo hello Kubernetes, and then it's going to exit. And I want you to think what's going to happen after it exits. Okay, so, oh yeah, that's right. This one doesn't give output. I'm not sure. This has a K3s bug. All right, so, we're in a crash loop backoff. All right, so the pod ran, it completed, and it should go into crash loop backoff again in a second. Okay, so there it is. So when you launch something inside of Kubernetes, unless you specifically tell Kubernetes that the thing that you're launching is going to run once and then stop, Kubernetes expects that it's going to continue running. So when it stops for whatever reason, Kubernetes doesn't know why, it restarts it, and then it stops, and then it restarts it, and then it stops. And then Kubernetes is like, well, this is a total waste of energy. I'm not going to restart this thing right away. I'm going to wait 2 seconds. So it waits 2 seconds. It starts it again. It dies. It stops it. Or it dies. Kubernetes waits 4 seconds. It dies. It waits 8 seconds. That's a back off because it believes that the pod is in a crash loop. It will continue to increase that timeout up to 10 minutes before it starts over again. And it does this to prevent things from clobbering your cluster when there's obviously something wrong with them. It doesn't know if maybe this pod is dependent on a database that's not up and running yet or on some other thing in the cluster. Maybe it'll start working again later, but if not, well, it'll just try and start it at reasonable intervals. Let's delete that. So kubectl delete the pod myapp-pod. So for starters, you're never going to create pods because managing them. And really, you want something managing them that will allow you to change the image or interact with them. That thing is a replica set, but you're not going to create replica sets either. I'll show you in a moment what you are going to create, but let's just talk about what they are. A replica set defines the desired scale and state of a group of pods. So remember, copies of things are called replicas. So here, for example, we have 12 replicas of our pod running on 3 different nodes. If these were just pods and we lost one of the nodes, well, those 4 pods would go away and they wouldn't come back. But because we're using a replica set, Kubernetes understands that we want 12 copies. We had 8 copies, and so it started 4 more of them for us. That's called state management. Kubernetes functions with 2 types of state, the actual state and the desired state. Everything that you do with Kubernetes is telling it the desired state. And then it looks at the actual state. And if there's a difference between the 2 of them, it does whatever it needs to do to make the actual state the desired state, whether that's start, stop, move things around, delete things, whatever the case may be. And then it works tirelessly to maintain the actual state if anything deviates. If a pod dies, it restarts it. If it needs more scale, it does whatever it needs to do. The thing that you are going to create is called a deployment. Deployments create replica sets create pods. But deployments have an interface that allow you to start doing reasonable things with the application. So here's a deployment. We have 4 copies of a pod, and they're all running 1.0, version 1.0 of our application. We want to upgrade this to version 1.1. So we tell Kubernetes that this particular deployment should now be running version 1.1. And it begins to launch new pods running version 1.1. So it spins up 2 of them, and then it kills off 2 of the old ones, and then it spins up 2 new ones and kills off 2 of the old ones. And now we've done a rolling update of our application to the latest version. If something were to go wrong with this, we also have the ability to roll this back. And it's a deployment that gives us that functionality. So deployment looks very similar to what you've already seen. So we got API version, we got kind, and now here you see we want to start with 3 replicas. The deployment creates something else, so it needs a template to know what to create. And what it creates is replica set. And you'll see down here underneath the spec that this looks very similar to the pod that we launched earlier. We have a containers section, we have a name, we have an image, and in this case, we're also telling it that the pod listens on port 80. Now we could just do kubectl apply. Actually, you know what? Before we talk about that, let's talk about this metadata thing. Everything in Kubernetes has a label, has many labels, and labels are arbitrary key value pairs. There are some things that are set by Kubernetes, and there are some things that you can set yourself, and these are used. They're used with what are called selectors. Since pods can come and go, and versions can change, and things are dynamic and moving, you want to tell the replica set and also by proxy the deployment what it is supposed to be managing. You can't say manage these 3 pods with this IP address because those pods could go away and new pods could appear and they could have a different IP. You can't say manage the pods with this. I mean, pods are essentially clones of one another. So the way you want to tell it to manage things is you give them all a label. In the template, you see that we are labeling our pods with app is nginx. And then when the deployment creates a replica set, it is looking for things that have a label of app is nginx, and those are the things that it's going to take care of. What this means is that you can't have lots of things with the name app is nginx being managed by different stuff because wackiness will ensue. So you want to use labels in such a way that the combination of labels is unique. You could have different things with app nginx, but maybe they have environment is staging and environment is production, and you can do a logical and on the labels that it should be matching. So one deployment is matching nginx and staging, and the other one is matching nginx and production. Labels are totally arbitrary. Do whatever you need to do, label them however you want so that it both makes sense to you as a human and also is easy to programmatically define what Kubernetes is supposed to do with it. You can see that in fact, our deployment itself has a label of app is nginx. This is a good best practice to name all things that are related with the same name. Deployment, replica set, pods, app, nginx. So we could just apply this like you saw me do with the pod, but instead, let's do something different. kubectl create a deployment called nginx, and we want it to run the image nginx 117 alpine. This is a much better way to do things than to create a bunch of YAML by hand. Now you can see that, well, that's creating, and in just a moment, it's running. Looks like I also have an old deployment out there. Let's delete that because I'm going to need to recreate that in a moment. One second while I continue to clean up here. We're going to talk about services and ingresses in a second. Okay, so as not to confuse you guys, what do we got now? We have, all right, we have one pod running. If we want to get replica sets, you'll see that we have a replica set. And if we want to get deployments, you'll see that we created a deployment called nginx. It in turn created a replica set, and that in turn created one pod. If we were to delete that pod, Kubernetes will restart it. So there you go. Previously it was BQGSV and now it's STGVD. With deployments, we can start doing things like scaling up the number of replicas. So now we've got 3 replicas. That's what a deployment allows you to do. It'll also let you update the image. Oh, we're already running 1.17. Let's make this whatever. Let's say 1.15. By using -- record, it tells Kubernetes, remember the previous states of the deployment from previous upgrades so that if we needed to do a rollback for whatever reason, we could. Once you have a rollout happening, kubectl rollout status deploy nginx. You can watch the rollout happen, and it'll tell you, okay, 1 out of 3 updated, 2 out of 3, 3 out of 3, and then it'll tell you about the ones that it is terminating. But I know that we could actually sit here for the rest of the class, and this is never going to give us any additional information because something went wrong. So you see now we've got 3 running, but we've got 1 in a state called error image pull. And maybe we don't know what that means. Before we go digging into that, obviously there's an error. I want to point out that this Kubernetes launches things before stopping old things by default. You can tell it to do otherwise, but by default, the rollout strategy is to create new things and then stop the old ones. So right now, the application is still running, users are still on it, nobody knows there's a problem, nothing is impacted, we're not going to get fired. So we have the time to figure out what we need to do different. Now, had this container launched, had this pod launched, we could go and we could look at the logs for it, but it never launched. So we need some other way to figure out what it's doing. Check and make sure that I am relieved to see that nobody else is reporting questions that the audio and video is broken. So we'll continue. When you want to look at what Kubernetes sees about any of the objects running inside of it, you use kubectl describe. This shows you how Kubernetes sees things and gives you a lot of information. So you've got the name of the object, various other things, what node is it running on, when did it start, what labels does it have. But what we care about is down here at the bottom, which is the events section. This is everything that has happened to this particular object since it was created. You see it was successfully assigned to a node. We tried to pull an image. We failed to pull the image. And the error message is that, 1.15 alkne has not been found. Then I realize, oh, I spelled it wrong. So of course I can't find it. Well, let's undo that. And now you see that it just stopped the update. Everything is still up and running the way that it was before. And let's change it differently. If you run kubectl edit, kubectl will reach out to the Kubernetes cluster, pull back the YAML for the particular object, and then display it for you in your editor of choice for you to modify. So here, I'm going to say 1.15, and I'll save it. Now it is automatically applied to the cluster. Let's see. And now if we watch our rollout happen, you'll see that it will actually complete successfully. And now we're running the latest version. Well, actually a previous version, but now we're running a different version. So let's delete that. And let's apply the manifest that I have locally because it has that port definition in it. And let's move on to the next thing. So you've got an application running, got a deployment, you got some pods, that's all well and good. Probably you want to talk to it. The next thing above what you've just created is a service. Pods have IP addresses, but as you've seen, pods can come and go, they can get deleted, they can get restarted, and every time that happens, they get a different address. So you can't trust them. What you want is a service which creates a DNS entry and a stable IP address, and then it tracks through selectors the things behind it. So it knows which pods are within its responsibility, and when you hit the service, it routes the traffic to the appropriate pods. It's essentially a layer 4 load balancer. Traffic arrives on a port, gets directed to something else behind it, and then returns to you. There are 3 different types of services. The first is a cluster IP service. Cluster IP service exists only within the cluster. So imagine that you've got a bunch of Apache pods and a bunch of PHP pods, and you want the Apache pods to talk to the PHP pods. So you create a cluster IP service in front of the PHP pods, and that's where you send your traffic from the Apache pods. That service never needs to be visible from outside of the cluster. So a cluster IP service is completely appropriate. The next type of service is called a node port. Each of these is recursive. So if you create a node port service, it first creates a cluster IP service, and then it opens up a port on every single node in the cluster between 30,000 and 32767. Traffic lands on that port on any of the hosts, it gets routed to the service, and then it gets routed to one of the pods, and then so on and so forth. Now, these aren't actually real things. It's not like it creates a load balancer for you. These are just logical objects that Kubernetes is managing, but their existence is entirely defined within the IP tables network stack. So node port goes to a cluster IP, goes to that. Now, node port services are they're specific use case services. You're obviously not going to tell somebody, hey, my website is at example.com:31336. So what can you use them for? Imagine that you launched a MySQL cluster inside of Kubernetes and you needed to load data into it from your workstation. Well, you could create a node port service, which creates a cluster IP service, and you could then send the MySQL client to 31336 or whatever port it creates, load all of your data, and then just change the node port service into a cluster IP service for things to consume it within the cluster. That's perfectly reasonable. The place that you'll most commonly find node port services in use is with external load balancers. So if you've got something outside and you want to load balance traffic within a Kubernetes cluster, or load balance resources within a Kubernetes cluster, you would create a node port service in front of, for example, those Apache pods, and then you would load your hosts and that port into the node pool of the load balancer. Traffic lands on the load balancer and it gets routed in, and that's that. If you're using an external load balancer, you probably don't want to be in the business of manually maintaining that information. So if your Kubernetes cluster is in a cloud provider, Amazon, Azure, Google, or one other exception that I'll show you in a second, you can create a service of type load balancer. And what happens is, first it creates cluster IP, then it creates a node port, and then the Kubernetes cluster reaches out over the cloud provider's API, assuming you've given it the credentials or the host policy to do so, and it creates a load balancer within the cloud provider, Amazon ELB, or whatever the load balancer is for the cloud provider that you're using. It then populates that load balancer with the node pool for all of the nodes in your cluster, the port for the node port, and then it maintains the health of that object for the life of however long it's around. So now as nodes come and go, you don't have to also remember to go out and update the load balancer. The Kubernetes cluster does that for you. If you are not in a cloud provider, if you have an on-prem installation, and if you want to use service of type load balancer, you want to use MetalLB. MetalLB is an in-cluster resource that you give a pool of IPs to. So you say, okay, here's 10 IP addresses that you're responsible for. And when you create a service of type load balancer, it allocates one of those IPs to a host in your cluster, and then it begins ARPing that address is on that host, specifically on that MAC address. Now, when traffic comes in for that host, it goes to comes in for that IP, it goes to the correct host, hits the service, and gets routed internally. This only works in places where you can have multiple addresses on a single node, so it generally doesn't work for cloud providers. MetalLB will also do injection into BGP. So if you have a BGP infrastructure and you want to get your stuff out that way, MetalLB will also work for you. like I said, it's essentially a layer 4 load balancer. So there's a picture of what a layer 4 load balancer would do. But what it actually looks like is this. So kind service label app is Nginx and the spec. So we have to tell it the port and the protocol and the target port that it's sending to, as well as what label to look for with the selector. By default, it does round robin load balancing. You can configure it to do session affinity and some other affinity type stuff, but we're just sticking with the defaults today, and type is cluster IP. But keeping in line with the fact that we don't want to be writing a whole bunch of YAML every time we need to do something, let's just expose our existing service. In fact, let's do that differently. Let's make that a node port service. So kubectl expose the deployment called Nginx, and we want it to be of type node port. Now when we get service, you can see, I lost my mouse again. Now we get service, you can see that we have an Nginx service. It's of type node port, and it is here on port 31846 on all of my nodes, and then it's routing to port 80 on the service object, and then it'll be routed to whatever port, in this case, port 80 on the hosts themselves. We can see this if we come out here and we go to 31846, and there's our Nginx welcome page. Woohoo! That's boring. Services, being not smart, are useful for non-HTTP protocols as well. So if you have MQTT, if you have something that has a TLS layer baked into the container itself, database type stuff, those things are also good candidates for services. But if you're dealing with HTTP traffic, APIs, websites, anything that speaks HTTP, then you may want to look at ingresses. The question is going to come up of, well, why would I use an ingress when I can just do service of type load balancer and just kick off a bunch of ELBs? And the reason is because it's a one-to-one relationship between cloud provider load balancers and services. So if you have a Kubernetes cluster and you've got 100 different websites on it, you probably don't want to be paying Amazon 100 times $18 every single month just to have services of type load balancer, when instead you can have 2 or 3 nodes dedicated to being a layer 7 load balancer as part of your Kubernetes cluster. Ingresses are served by a thing called an ingress controller. An ingress controller is a software-based load balancer like Nginx or HAProxy, or an API gateway like Kong or Glue, or it could be Istio, has ingress functionality as well. These are things where you can define rules for host and path, and optionally port, that control how traffic is routed within the cluster. They sit in front of a service and they make decisions. Now here, it's pretty easy because it looks like it's just a single service, but imagine you're building a microservices application and you have different sections of your site that route to different things. Slash products goes over here, slash store goes over there, slash profile goes to these pods over here, because you've got all of your stuff written, in a super granular fashion. All of that can be sitting behind a single ingress, and you can have those routes handed off to different services and thus going to different pods. Let's first change this back to a cluster IP service. And then let's look at what an ingress looks like. The part that matters is here. So the host name is training-a, and we want to send slash to the service called Nginx on port 80. You see that my service, now that it's just a regular cluster IP service, well, it's just listening on port 80. All right. So there's our ingress. And if we go back to our browser, well, now, instead of this ridiculous port, we just go to the URL and it looks exactly the same. This is still really boring. Let's take what we've learned so far and let's make this a little bit more exciting. I have a better container image called Rancher Demo. So first, let's look at what we have. We have a deployment called Nginx. Sitting in front of that, we have a service called Nginx. And sitting in front of that, we have an ingress called single ingress. If we want to change the image of our site, well, all we have to change is the image that the pod is running. So let's do kubectl set image deploy nginx. Even though we only have one container, we still have to tell Kubernetes the name of the container we want to change. So we can watch that roll out. Okay. Now it's all still called Nginx. The name of it doesn't actually have anything to do with what it's running. It could be called, whatever, Adrian's favorite application. Because we changed the image here, though, I know that this particular container listens on port 8080 and not on port 80. So let's edit the service and let's change the target port to 8080. And with that done, we should be able to refresh over here and get a bunch of errors. This happened last week as well. I have to update the image. I totally forgot about this. Okay, so let's talk about troubleshooting. We've got errors. In this case, the errors aren't within Kubernetes. The errors are actually within, where's the network tab? The errors are right here. Oops. K3s runs traffic as its ingress controller by default. And this particular container is using a URL of /ping to get its updates. Well, traffic intercepts /ping to return a status of OK, which my little application doesn't recognize. So this is actually a problem. The way that we fix this is we need to update the image that it's running to a later image that just has a slightly different tag. So let's come back over to the terminal. And let's just do this. Okay, that already rolled out. That was really fast. If we come back over to the browser and refresh, then we should now see 3 replicas. You can see the host name is changing as it load balances across the different backends, and you can also see the little green icon telling you which of the little cows are in play. This allows us to do things like scale our replicas up to 5. And if we come over here, we'll see more replicas scale in. And we could do the same thing in reverse. We could scale stuff out, and we would see them disappear. It just takes a little while for it to do that. That's the basics that you need to know for how to get up and running with Kubernetes. You've got deployments, which create pods. You've got services, you've got ingresses, and other Kubernetes things sit on the periphery of that. You have things like config maps and secrets and volumes and storage and stuff like that. We'll talk about a little bit of that when we get to the Rancher portion in a second, because it's a lot easier to do with Rancher. But these are the fundamentals. we're only working with deployments today, but there are other types of things that you can do within Kubernetes. Deployments deal with stateless traffic. Like HTTP is a stateless traffic. So stateless means traffic can land on any one of these pods and it doesn't matter. I can delete one and replace it with something else and it doesn't matter. They're exactly the same. They're very, very simple and they're completely stateless. But that's not true of things like a database, for example. If we had a master and two replicas, whether it's MySQL or MariaDB or Redis or whatever, well, they're important. The master is the master. It's not, it matters. It matters that it comes up first. It matters that it has a stable name. It matters that it has a reliable IP. It matters that the replica can find it. It matters that it's using a particular storage volume. Things that matter would use a stateful set, which is a different type of controller. So deployments, stateful sets. There's also a daemon set, which will launch one copy of the pod on every single node in the cluster. If you have 3 nodes, you launch a daemon set, you get one pod on each of the 3 nodes. If you add a 4th node, it will automatically get a copy of the pod. That's great for things that do maintenance jobs or where you want, for example, your ingress controller, you want to have 3 of them listening. You don't want them all listening on the same host. Then there is a job, which is really the thing that we launched at the very beginning. A job is a pod that starts, does something, and exits, and Kubernetes is not going to restart. If you want it to be started on an interval, then there's a cron job, which is exactly what it sounds like. It just starts jobs on an interval. Those are great for things like backups or maintenance tasks or stuff like that. But to get started, you now have everything that you need. So I will pause here to scroll through the questions, and then we will move on to the Rancher stuff. Let me pop this window out here and see what we've got. Once I get past all of the terrible quality screen. Okay, so Masood asks, so -- record sets a status of a deploy. -- record tells Kubernetes to remember the previous state. So let me jump back to my terminal here. So right now, well, let's see. So kubectl will give you help. So if we look for the help for rollout, so we can say kubectl rollout history. And whoops, deploy nginx. I guess that helps, right? Okay, so here you can see the previous states of the thing. So first, we're at state number 3 right now. Previous state was state number 2. That one didn't work. We could roll all the way back to number 1 if we wanted to. The reason is because we've been using -- record. If you don't use -- record, you lose the ability to roll back to previous states. I don't know why it's not the default. I think it should be, but there might be times where you don't need Kubernetes to maintain this information. Can I talk about Vagrant? I don't know what to say about Vagrant. Vagrant is I mean, I know you have a specific request that you want me to talk about, so Vagrant is a front end, a command line front end for VirtualBox. It allows you to deploy boxes and reliably and programmatically deploy virtual machines. We have a quick start for Vagrant for Rancher, which will launch 3 nodes and a server and install Kubernetes with Rancher OS. And that's a cool way to get started as well if you're looking for something that's a little bit more complicated. You're asking me about XPIO and ports, Salim. So if you could clarify what you want to know about that, I would try to answer, but I make no promises. Masood's asking, how can we get this code? Good question. I don't know. Where is it? Rancher Kubernetes training. Get. More OSCAPs. There it is. I haven't updated it in forever, but after this, I'll make a note to push changes. So you can check back and you'll see that some of these are updated. It's basically the same as what I've been doing the whole time, but this also includes my notes, so you can see my whole cheat sheet of everything that I do during this class to show stuff. We never get to config maps, which is a shame. Yeah, so there you go. I'm OSCAP'd, Rancher Kubernetes training. Replica means service instance. No, a replica is a copy of the pod. So let's come back over here. So right now we have 5 identical copies of this Nginx pod running, and those are replicas. So if I wanted to scale that down to 2, for example, well, you'll see that 3 of these are going to go away. And if we jump back over to the browser, you'll actually see that they go away over here as well. So that's replica is just a fancy way of saying clone. I have an application which is running in 2 nodes with a load balancer of 2. The same scenario, how will it exist in Rancher? The application which is running in 2 nodes with a load balancer of 2. Rangaswamy, I don't understand the question. If you could ask it in a slightly different way or give me more information, I'll try to come back to it. Okay. Let's move on to the Rancher stuff, and we'll see if Rangaswamy can come back with a question. And yeah. Now, there are, should I have anything else on slides? I don't. Good. No more slides. Let's look at the docs. If you go to the Rancher docs, there's the quick start guide. Meh. Come down here under installation, and you'll see that there's 2 ways to do the install. There's a single node install and there's a high availability install. We're going to do the single node install today, but only because we don't have time to do the more thorough installation. The primary difference between them is that the single node installation is where you just run a Docker container. I mean, Rancher just runs inside of a Docker container. That's fine. It's fine for playing around. It's fine for a sandbox environment. But if you think that you might want to move to a high availability install later, if you think you might put production stuff onto it, if you find that you like it, you should start with an HA install, because there's no way to go from a single node Docker container installation to an HA installation. So if you start with the one and you put a whole bunch of cool stuff on it, and then you want to move to the other, you're going to have to redo all of your work. But you're probably sitting there being like, well, Adrian, I don't want to dedicate 3 nodes to Rancher just to start. I just want to dedicate 1 node. That's fine. When you come down here to the install Kubernetes with RKE section, it's going to give you an example config file. And here you see that there are 3 nodes. Just make one. Just create 1 node, make it all 3 roles, control plane worker and etcd. And when you run RKE up, you will end up with a 1 node Kubernetes cluster into which you'll install Rancher. You just continue with the rest of the steps over here on the left. Later, if you decide that you're ready to go to a 3 node HA, you can just come back into the config, add 2 more nodes, and run RKE up again, and it will recreate, sorry, not recreate, it will expand your cluster into a 3 node HA cluster with 2 more etcd nodes, and it'll wire them all together, and now you're fully HA without having to redo any of your work. This is how I recommend you start. And well, we'll talk about my videos at the end. I actually have videos that show you how to do all of this. Hey, Masood says he installed an HA installation successfully today. Awesome. Glad to hear it. We're going to do the single node install. And the single node install happens with a Docker run command. So let's go log into my server over here. Nothing running, but I do have 231 Rancher. Okay. Oops. Man. I'll explain this in a second, so don't be alarmed. Okay. Docker run d for daemon, restart is unless stopped, because if you don't do this, when you go to do an upgrade or backup and you stop the container, Docker's going to restart it for you, and then you try and stop it, and Docker will restart it, and it's really frustrating. You end up having to delete the container, and then you don't have a backup to go back to. So restart equals unless stopped. We're going to punch through port 80 and 443. And it's not in our docs, but if you're going to do this way, I recommend that you bind out a directory on the host. In this case, I'm going to do opt rancher to var lib rancher inside the container for persistence. It will create a Docker volume for you otherwise, but when you go to do backups, trying to make backups with Docker volumes it's a pain. And the rancher documentation for how to make a backup is also kind of a pain. If you do it this way, all you have to do is stop the container, make a copy of that directory, and start the container again. And that's a much easier way to make a backup. And then we'll run rancher 2.3.1. This will take a moment to start up, but it actually gets running to where you can talk to it relatively quickly. Let's go to this tab here. That's interesting. That should already be up and running. There we go. Okay. So Rancher installs by default with self-signed certificates. Just took a few seconds longer than I thought it would. Self-signed certs, but you can bring your own certs. You can bring your own self-signed certs. You can bring real certs, or you can launch it where it requests certificates from Let's Encrypt. So all of that is in the documentation. In our case, since we just launched it without any other options, we get the self-signed certs. So we'll say, yes, 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 I accept the risk, the dangerous risk of the self-signed certificate. First, it's going to ask you to create a password. So there's that. This part about collecting anonymous stats. Oh, did I screw up my password? Okay, there we go. So we ask you to let us collect anonymous telemetry data. It's completely anonymous. The information that we collect is basically how many clusters are running and what version of our software is running inside of it. This mostly allows us to determine when we do upgrades or releases or emergency bug fixes or anything like that, how many people still haven't upgraded off of a particular version. But like I said, it's totally anonymous. If you're not comfortable, you can turn it off. Just uncheck that box. You'll actually get another question here in a second. But it does help us a lot. This Rancher server URL is important. When you deploy or import or whatever clusters that Rancher is managing, those clusters need to know how to reach into the Rancher server to open a WebSocket connection and request information about what they're supposed to do. Rancher also reaches into them over the Kubernetes API, but this URL here needs to be something that the clusters can reach back into. So don't, for example, create a Rancher server in your office and a bunch of clusters out in Amazon and then give like a private IP inside your office that they can't find. It's theoretically possible to change this later, but it's a little bit of a pain, so it's worth getting it right. It's also worth not using IP addresses here, because if you use an IP, especially if it's a dynamic IP, and your Rancher server goes to a different IP, your clusters are all going to freak out and they won't be able to connect to the Rancher server. They'll still run just fine, but you're going to lose the management component of it, and you'll have to try and figure out how to make stuff actually update. So with that done, here's the request for collecting telemetry data, and we're taken to the global screen. We have no clusters. If we did, they would all show up here, cluster after cluster after cluster. We'll say add cluster, and here you're presented with a bunch of different options. You can stand up infrastructure out in a cloud provider and we'll install onto it. You can stand up hosted Kubernetes providers. You can do the import that I told you about. You can do the custom that I told you about. So today we're going to import, but I'll show you custom first. Custom is where I normally work because I tend to use Amazon auto scaling groups. And So let's see, if we said this was custom demo, you can set some options here. We'll say next, and it will say etcd and control plane, and you see that it gives me a Docker run command here. This is unique to the cluster. So this is the command that you would put at the end of your provisioner, whether it's an ASG or Ansible, Puppet Chef, blah, 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 all of those. And now when you stand up new nodes, they will automatically join the cluster. But since we're not doing an RKE deployment today, let's just delete that. And we'll come back and we will import our existing cluster. I'll say create. And this gives me a kubectl apply command that I can run. It actually gives you a couple of them. So this top one is only if you're using Google. The middle one is the one that you would normally use. But if you're running a Rancher server with a self-signed certificate, then kubectl won't talk to it. So instead, you need to run this last one, which is what we're going to do. This sets up custom resource definitions and installs the Rancher agent. And we come back over here, and we'll see in a moment that stuff will start to appear. Now, it does take a moment as it pulls down the container images to deploy things. So while that's happening, I want to talk about the global stuff that's up here at the top. We're in the global section. First, let's talk about security. Here's where you connect Rancher to some backend identity provider, AD, GitHub, Ping, all these SAML providers, OpenLDAP, or new in Rancher 2.3 is Google authentication. Imagine that you're in the ops department of a company and you're responsible for managing Kubernetes clusters for multiple teams. Different developers have access to different clusters, possibly in different providers. And when somebody joins the organization, you have to figure out where to go and put access credentials. Is this cluster in Amazon? Is that one in Google? Is this one in Azure? And if somebody leaves the organization, you have to figure out what did they have access to so you can very quickly go and try and disable all of their stuff. Anytime that you need to do things in multiple places, it's an opportunity to make mistakes, and mistakes are expensive. By using Rancher's centralized authentication, if somebody joins the organization, you just put them in the correct Active Directory group or put them in the correct GitHub organization, and suddenly they have access to the clusters that they need to have access to. And if somebody leaves the organization, you just deactivate their account in Active Directory, and they lose access to everything that they had access to. You never need to provision credentials in specific cloud providers. You only need to provision it in the authentication system that you're already using. You can also add users directly into Rancher. So we recommend that you always keep an admin user in here so that in the event that Active Directory is down or something happens, you can still access Rancher and access the clusters that way. We also do full management of Kubernetes role-based access control at the global level. So you can either add new roles or you can manage existing roles. So these are the definitions of things. I mean, Kubernetes RBAC is phenomenally complicated, and Rancher makes it really easy for you to see the features, the roles and the permissions that somebody has. And then you could inherit from this. You could create a new cluster role that inherits from a particular role and then assign that to an individual user or a group as the case may be, to do whatever it is needs to be done. Same is true of pod security policies, also managed at the global level. We ship with restricted and unrestricted. A PSP tells Kubernetes what types of things pods that run within it are allowed to do. Can they run as root? Can they use host-based networking? Can they run in privilege mode? What capabilities should they have? You define the parameters, and then if somebody tries to launch a pod that doesn't follow those rules, Kubernetes won't let it. This is another thing that you don't want to be changing on all kinds of different clusters. So you can create PSPs that adhere to your security policies and then apply them to the different clusters where you need them applied. You saw when I launched stuff that there was like the big three, there were some cloud providers, but we support more than that. We support a number of cloud providers, and you can add additional cluster drivers. You can also add node drivers from anything that supports Docker machine, or you can just activate the ones that are already in here. So if you're using Packet or Rackspace or something like that, you can just activate it and deactivate the ones that you don't care about. And from the add cluster screen, you'll get access to those as options. The package management system for Kubernetes is called Helm. If you're coming from the Linux world, you're familiar with things like dpackage and yum and apt and yast and things like that. Well, for Kubernetes, it's Helm. Rather than me creating a README file that talks about a whole bunch of different steps that you have to follow to deploy Adrian's application, I could package it all up and make it available as a chart within a repository. You can add that repository, and then you can just say Helm install Adrian's app. And you can set configuration options via key value pairs that that determine how the app is actually deployed within your particular cluster. I'm going to show you the Rancher app catalog in a moment, and we ship with the Rancher library enabled by default, as well as the system library. If you want to use the Helm stable repo, you can activate it here. There's also the Helm incubator repo, which has less stable applications. And you can add any external Helm repository for internal, external stuff, whatever you want, and those things will become available for deployment in the app catalog that you'll see in a second. By now, our training cluster is up, and you can see that there are two projects here. Kubernetes breaks things logically into what are called namespaces. You can't have two deployments called website within the same namespace. You can't have two deployments called whatever, called the same thing within a particular namespace because Kubernetes doesn't know how to differentiate them. You can have a production namespace and a staging namespace and a development namespace, and inside of each of them, you can have a deployment called website. But now we're back to the place where role-based access control needs to be applied per namespace. So you've got developers who need access to multiple namespaces, and you're back in the business of putting things in multiple places. To mitigate that, Rancher collects namespaces into a logical object called a project. You can apply role-based access control to the project, and it is automatically applied to every namespace that exists within the project. Do things once. When you first install Rancher and first, whether you deploy a Kubernetes cluster or inherit one or whatever, there's the system project, which has system level stuff that you probably shouldn't be playing around with, and then the default project, which by default contains the default namespace. At the cluster level, you can see additional information about the cluster itself. So you've got stuff going on here. This is pretty basic. If you have a cluster with more CPU than what I have on my little single node that I'm using for the training, you can click this link up here to enable monitoring and accept the defaults or whatever, and you will get a full deployment of Prometheus and Grafana that operates at both the cluster level and the project levels, meaning that users who have access to a specific project will only see metrics for their particular project. Projects themselves give you single cluster multi-tenancy. So a user who has access to a project will actually only ever see anything that's related to his project. He can't see other projects, even that are on the same system. If you use a networking provider that supports network policies like Calico or Canal, Canal is the default, you can set it up where his workloads can't even see other workloads running in other projects. And this allows you to implement single cluster multi-tenancy, which is where you have a larger cluster that you could use for developers, for example, but you can still carve it up in such a way where either a project could be for a team or a business unit or a customer or anything, and they will not be able to see or interact with stuff from other projects on the same cluster. So let's jump back into the default here. Where it tells me that there are no workloads deployed. That's totally bizarre. That's not right at all. This is the part where my demonstration totally breaks down. So with that import, we should have actually seen all of the workloads that we had running inside of it. Okay, so let's go look at the nodes. Let's make sure that we're actually pointed at the right cluster. Yeah, training-A. Huh. Default. Okay, so namespaces. Oh, that's weird. Namespace all, default, kubectl node lease. Now we get into the troubleshooting portion. kubectl node lease, cal system, default. So I'm checking to make sure that I'm in the default namespace, that I wasn't deploying stuff into some other namespace, which I might have been. No, so I'm in the default namespace. So this is, for some reason, broken. Well, the stuff that we had deployed was supposed to show up here and did the last time that I did this, but let's just move on and let's just deploy something new. And then we can see if it shows up in the cluster. I mean, I'm not really sure where the discrepancy is here. We can say deploy, and let's deploy something called demo. So this is effectively going to create all of the Kubernetes resources behind the scenes, the same as if we used kubectl directly or if we imported YAML that we built from some other means. So let's go with Monakas Rancher demo. Yeah, there's a problem with namespaces. Hang on a second here. Namespace all, namespace all, namespace all. Project default does not have the default project in it. What gives? Let's move that to the default project, and let's see if this suddenly starts working. Ha! Look at that. Okay, so when we did our import, for some reason it didn't actually import the default namespace into the default project. I've never seen that happen before. But what I just did was I went up here at the cluster level to projects and namespaces, which is what you see here. And I saw that, here's the default project, which didn't have anything in it. And here's actually the system project, which also doesn't have anything in it. These things are system level stuff. So I'm going to select the three of them, and I'm going to move them to the system project. And now they would show up over here. So we're in the default project now. We're back on track. We're at workloads. You also have load balancing, service discovery, and volume. So I'll go through the menu stuff at the top in a second. Here's the Nginx app that we already deployed. So you can see that it's listening on 80 HTTP because we have an ingress over here called single ingress, which is going to the Nginx service. We could edit this and we could make changes to it. So for example, I know that this particular container allows me to set cow color. Let's set that to pink. We can also do lots of other stuff, like we can enable health checking. So if we want to say get / on port 8080, well, Kubernetes is going to check that every 2 seconds. And if that fails, it's going to restart the pod. Let's just save those. And now you see Kubernetes will do a rolling update. And in a moment, we will have new pods running. And it's going to stop the old ones. If we ran into an issue, there were questions about rollback. So here we have the option to visually see all previous iterations of the application, and we could roll back to any of them. So we're up and running now. And if we come over here, you can see that now we have pink cows instead of black cows. And those black cows are going to fade away. Rancher doesn't hide anything from you. Everything that I'm doing here in the UI is actually talking to the Rancher API. And we can just come and say view edit YAML, and it's the same as doing a kubectl edit. You see that this is the full range of YAML. Let me find my replicas. So there's replicas 2. Let's just change that to 4 and click save. And now it's going to launch 2 more replicas. We could also control replicas here. One of the things that's fantastic about Rancher is you can give Rancher to people who don't have a lot of Kubernetes experience, and they can start using the power of Kubernetes without having to learn everything that's going on. So we could say, for example, we want to deploy a new workload called training. We want a scalable deployment of 2 pods, but you can see here are the other controller types that are available. This one will just run, whatever, we'll just run Nginx again. Alpine. It's going into the default namespace. We'll open up port 80 and we'll make that a cluster IP. We don't need to set anything else. We could set a health check if we wanted to. We could attach storage if we wanted to, whether that's from persistent volumes or from config maps or secrets. We don't cover storage in this class because it's a little bit more advanced. You can start to control how things should be updated. Start new pods and then stop old ones, stop old ones and then start new, kill everything. How do you want to do that? And then down under advanced options, you have a lot more things about security options and labels and annotations and stuff that, you know, when you get a little further in your Kubernetes journey, you'll understand where you might want to use these things, overriding commands, for example. And then we can just say launch. Because we defined a port, Rancher will automatically create the service for us. And we could now come out here to our load balancer, and we could, for example, edit this. And we could change the target to go to the training service if we wanted to. Or we could create a new service, a new ingress. We'll call this training. Let's automatically generate an xip.io hostname. Let's not use a workload type, but instead let's use a service type. We'll send / to training, and we'll say save. And now you see that it's given us a URL. And if we select that URL, well, then we're taken to our new thing. So that right there is essentially the stuff that we did via the command line in the first 40 minutes of this class. Takes seconds to do in Rancher. Rancher provides additional, more advanced benefits than what we have time to go into today, but I just want to run through them so you have an idea of what exists out there. If I come out to the cluster level, you see that we can provision notifiers. So you can define where to send stuff: Slack, email, PagerDuty, arbitrary webhooks. Once you define a notifier, then at both the cluster level and at the project level, you can configure alerts. So at the cluster level, we have things related to the cluster itself. So etcd, kube control, or kube components, events, things like that. And you can define each of these and say where they should go. You send them to a particular notifier. The same is true at the project level. You can ship logs also at the cluster or the project level to arbitrary endpoints: Elasticsearch, Splunk, syslog. If you have an Elasticsearch instance, just tell us where it is. We'll start shipping logs. Same with Splunk, same with syslog, all of it. Oops, I don't want to save that. Monitoring is not enabled. This is the project level Prometheus and Grafana that I talked to you about earlier. And then we have Istio, which is definitely a complex item. Rancher 2.3 enables you to deploy Istio with just a couple of clicks, and then you can activate it per namespace. So if you're interested in using Istio for service mesh, you don't have to worry about figuring out how to install it. The configuration of Istio is still done through Istio objects, but in future versions of Rancher, we may include Istio configuration as well, within the UI. Also out here at the global level, you can create storage classes. Storage classes are a way to tell Kubernetes how to provision storage so that people can request storage via the storage class when they launch workloads. So we could say Amazon, EBS disk. There are other options here that you can configure. And then when somebody goes to launch stuff, they would be able to say, I want 10 gigs of storage from EBS, and the Kubernetes cluster will provision it and then give them what they need to actually attach that to their specific workloads. You can also directly create persistent volumes in all sorts of different volume types that Kubernetes supports. So if you have NFS, for example, you could pre-provision an NFS volume and make it available for consumption inside. Here in the project level, you see that we also have alerts and catalogs, logging, monitoring, and now we introduce pipelines. If you don't have an external CI/CD system, you can just point Rancher at one of these providers and give it your access credentials, your personal access token, and you can configure rules that will build, update, and deploy that will update running workloads from things like code pushes. So it's a stripped down version of Jenkins. It doesn't replace a full production CI/CD system, but if you have nothing, it's a great way to get started with continuous delivery. Also in here under resources, we have also new to 2.3, you can provision horizontal pod autoscalers. This is a thing that runs inside of a Kubernetes cluster that monitors something such as CPU or memory consumption within a pod. And if it crosses a certain threshold, it will scale the number of pods up. So you would use this for automatically growing the number of replicas when there's more traffic and shrinking the number of replicas when there's less traffic. You can provision it based on other things like requests per second or other metrics, but those require that you deploy an extra adapter to be able to gain access to those metrics for decision making. Secrets and config maps are also configured over here. The last thing that I want to show you before we go through the last of the questions, and looks like we're already a few minutes over, is the app catalog. Imagine you're a developer and you want to build an app and you want it to talk to Hadoop. So you've got this Kubernetes thing, but you don't know how to deploy Hadoop within Kubernetes. You certainly don't know how to deploy Hadoop within containers, and you aren't being paid to figure it out, but you do need to build this app. So you could come here to the app catalog and you could say launch, and you could scroll down to, or you could just search, find Hadoop. Select that, and there will be questions here that you can fill out in the form. The defaults are probably sensible. If you want persistent volume, you can turn that on. You can set a storage class, or you can pick an existing persistent volume. You can decide whether you want a load balancer. So each of these questions is unique to the application that you're deploying. But like I said, the defaults are reasonable, and you can click launch. And this will build you a multi-node replicated Hadoop cluster that's all wired together and hand you back an endpoint that you can start using with your application. It takes a few minutes to deploy, and now you can just get back to work. There are a number of applications here that we ship with the Rancher library, and these aren't necessarily supported by Rancher, but they're things that we ourselves use, and we at least guarantee that when you go to deploy the MongoDB replica set from the library, that it will actually deploy. Mongo is responsible for supporting what happens inside of it. If you had enabled the Helm stable repo, for example, you would see all of the Helm stable stuff in here as well. The difference between the Rancher app catalog and Helm charts is that Rancher apps have this question answer form that's more friendly. Our documentation shows how to take a regular Helm chart and add an extra single file to it to generate this list of questions and answers. So if there are Helm things that you want to make available as Rancher apps, you can just make your own catalog and define the questions file for it. Or if there are your own applications that you want to make available for downstream users of your clusters, then you can also either just create a Helm chart, or you can use this particular format. The final thing, the last thing about the app catalog is actually out at the global level. there's this restaurant in the United States. If you're here from the US, you probably have heard of Chick-fil-A. If you're not from the US, you might have heard from Chick-fil-A, but they're a restaurant. They have over 2,000 stores, that's what they call them, across the United States. Each of those stores runs a 3-node Kubernetes cluster. I don't know what that cluster does, but it's responsible for managing in-store resources, the fryer or the point of sale system or whatever. When those guys want to do an update of some application, they update it across all of their stores. They don't go to each of the 2,000 stores manually and perform that update. They can use something like the Rancher app catalog, but at the multi-cluster level. This is exactly the same as what you just saw in the cluster level app catalog, except here, when I go to deploy something, where'd that Hadoop go? Now I have the option to select projects. So I will see every single cluster that Rancher manages, and I can choose to deploy it into multiple Kubernetes clusters simultaneously. And then I can do updates of the application in multiple Kubernetes clusters simultaneously, complete with the ability to roll back failures and control the batch rate at which clusters are updated. This is the intro of Rancher's multi-cluster functionality, allowing you to do work on multiple clusters the same as you would do it on a single. Okay, I will stop there. Otherwise, I'll keep talking about stuff and let me scroll through questions. Looks like we don't have very many left. So I thank you all for staying the last few minutes. Let's see, one question about bare nodes from Masood. So after installation and installing Rancher Web UI, how can you add nodes to a custom cluster? I didn't see any option to add nodes to custom nodes, such as VM machine hosted on some type of system. Okay, that's a great question. Custom clusters. Let's jump back out here to global. I'll say add cluster, and we'll say from existing nodes, and let's just call this Masood. And I'll just say next. And here you pick the role. Now this Docker run command, let's say you already have a cluster running. So it's already got etcd and control plane and worker nodes. Well, as you see, when I add these, it just adds a flag down here. So if I add control plane, so it just added control plane. This Docker run command is specific to this cluster. So whatever Docker run command you used to launch the cluster, or I think actually, even if you come back here to edit the cluster, it will give you that Docker run command down at the bottom. So you can just add more workers by running this command on those particular machines. This is why I use this as an example for people who provision outside of Rancher, autoscaling groups, Cloud Init, Ansible, Puppet, Chef, Terraform, those kinds of things. Just define this cluster and put this Docker run command at the end of your provisioner. And now when you scale up the number of nodes in Amazon with an auto-scaling group, those nodes automatically join the cluster. Share the HA installation YouTube link. Yeah, so I have a YouTube channel. Adrian.goins.tv. I create tutorials about Kubernetes, about Rancher, about stuff. Now, while I work for Rancher, I actually create tutorials that show you good ways to do things, even when that's different from how Rancher does stuff. I do believe very much that Rancher has fantastic products and has a fantastic way to do things. But if I have 25 years of experience building internet infrastructure. So if there's something that I think will be easier for you, but just as secure, such as the earlier thing about bind mounting volumes for easier backups, that's what I put into my tutorials. If there's anything that you guys would want to see in those tutorials, you can let me know in the comments of any particular video, or every video also has a link to my Twitter account, so you can make requests there. And if you want something, like, I'm happy to make videos. Like I make videos every week, and I'm always looking for new content that will be helpful. So check that out. And in there, I have videos about Rancher installation, both HA and standalone, how to do backups, how to use Minio, how to do a whole bunch of stuff. All right, so it looks like the last question, how can we provide app catalogs by our own, suited for microservices, stuff like API and DB, one app catalog is desired. Okay, that is in the documentation. Come over here, and if we scroll down, let's see, catalogs and apps. custom catalogs, creating custom catalog apps. This will walk you through. So you see there's Helm charts, which you can just import natively, and then Rancher charts. Um, and then this will walk you through the chart directory structure and the additional files. So basically you would create a Helm chart and you would then enhance it with these additional files that Rancher needs in order to create the form, and the template versions and stuff like that. It's not difficult to do. Once you do it the first time, then it'll be really easy for you to do it afterwards. So you could create applications. You're asking about microservices. So you could create stuff that have a pre-configured combination of an API gateway and a database, or your specific application with all of the resources that it needs for that particular microservices piece. Or you could deploy your entire application where you could create a Helm chart that deploys multiple sets of pods, services, ingresses, and then all of the stuff that's needed for that. It's as dynamic as you want to make it. Pierre asks, how do we make communication between two environments? Kubernetes itself is designed to be self-contained. So there's nothing within Kubernetes that will allow you to communicate with another Kubernetes cluster. Things like the multi-cluster apps that I showed you, we jump out of the global here, things like multi-cluster apps, these work because Rancher can push stuff into multiple Kubernetes clusters, but those clusters themselves don't talk to each other. However, if that's something that you're interested in, there's a project. So Rancher has two types of things. We have projects which are open. First of all, everything that Rancher does, I didn't say this at the beginning, everything Rancher does is free and open source. Everything you see me doing today, 100% of it, you can just go do yourself for free. Rancher sells enterprise subscriptions for companies that want additional engineering resources, onboarding, support, access to feature requests for the product, or enterprise level stuff, but it's not required. There are things that are under Rancher's service level agreement that include all of the Docker engine, all of the Kubernetes components, all of the Rancher stuff, all of the cloud native computing foundation components that are embedded into the product. All of that is covered under Rancher's service level agreement when you have an enterprise subscription. Rancher products, some Rancher stuff is covered under the SLA. Things like obviously Rancher, RKE, Rancher OS. But we have lots of other projects that we're working on, such as K3S, K3OS, Submariner, that are either in development or moving towards a GA release. Generally, when something reaches the GA 1.0 status, it is then covered under the SLA. Submariner is one of those things that's not covered under the SLA. It's still a project, but you're welcome to use it. Lots of people do. This will create essentially a layer 2 VPN between two Kubernetes clusters. This enables you to start doing things like multi-cluster service mesh or schlepping data back and forth between two MySQL instances, instead of it having to go out and traverse the internet. Like, it's the start of Kubernetes fleet where you could use Kubernetes clusters themselves as availability zones and get into some pretty cool complex networking stuff. So Pierre, this is where you want to go to find more information about that. You're very welcome, Masood. Masood says, thank you, and I'm guessing you have to go. David asks, how do I export the Ansible node creation command into an Ansible playbook for all nodes? Okay, so that's an Ansible specific question. Find me on the Rancher user Slack. I'm Adrian, and I have a lot of experience with Ansible, and I will talk to you more about that. Rancher OS is great, but it's built from containers. We do not have apt or even a nano. Okay. Masood, okay, so Masood says Rancher OS is great, but it's built from containers. That's true. Rancher OS is an entire operating system built from containers, and it runs everything as containers. So you don't have apps and you don't have nano. Well, no, you don't, but you have Docker. So if there's an application that you want to run inside of Rancher OS, well, you just run the container, whether that's, and that works for commands as well. So like Rancher OS, there's no curl, but you could run a Docker container that has curl in it, and it's you just alias the command curl to be docker run dash dash rm curl, and then whatever. And with a little bit of extra work, I mean, it's not really extra work, but with a slightly different approach, you can have the same level of functionality. So you want Nano? Okay, well, so you can run a container with Nano in it and then just bring in whatever the volume is for your current working directory. Like there are ways to do everything with Rancher OS, but the reason that people use it is because it presents a very, very small attack surface. It's extremely lightweight. It's very fast to boot up. It's fantastic for environments like vSphere and ESX. Um, but yeah, it doesn't work like Ubuntu, but it's not Ubuntu. All right, any more questions? Uh, okay, so that's it for questions. So I'll just show that outro page again one more time. YouTube channel, my name is Adrian Goins. You can find me all over the internet. If you like the way that I talk, if you like what you learned today, you know, my channel is a great place to start. Rancher also has masterclasses for more advanced Kubernetes stuff. We do intros to K3S. We have a lot of training that we do every single week. So you can go to the webpage, look for events. There's also rodeos and lighthouse events where we will come to local cities and do on-site presentations. Those are usually co-sponsored with like Google or Microsoft. There's a ton of stuff available on the site for you to use to learn. And I guess with that, that's kind of it. Find me on the Rancher user Slack, follow me on Twitter. I am here to help you in any way possible. I think there's a survey at the end of this, so if you get that at the end, please answer it. That helps us figure out how to do better on these trainings, like how to not show you super small video at the beginning. Although I think that was a GoToWebinar problem. Again, join the Rancher user Slack. There's lots of people there who are invested in your success. Thank you all so much for coming, and I hope to see you again in a future training. Have a great rest of your day, or night, or morning, or wherever it is, wherever you are. Bye-bye.